September 13th and our weekly SIG Node. First, I want to welcome Sergey and thanks. And Sergey used to be together with the Alala and later Daniel driving off our SIG Node CI projects. So welcome back. And I definitely miss you. Yeah. So let's follow our agenda. And so the first one, it is, I think it is the Western, talk about the resource control plugin.
Yeah, so it's myself and Atanas. Actually, Atanas is going to present because he's done, we've been working together in the design, but he's done most of the implementation and even has a working demo of it. So Atanas, can you let him share?
I lost. Sorry. Can you make?
Yeah, sure. Let me make. Okay, I made you co-host.
Thank you.
So go for it. Yeah.
Yeah, let me try. Let me know when you see my screen.
No.
Let me try. Visible now?
Works now.
Okay, perfect. Yeah, thank you very much for joining today. So I will present our proposal, basically how we could have something like pluggable resource management inside Kubernetes. Looking forward to your feedback if this is a meaningful proposal for you. So in terms of agenda for the talk today, I will start with short summary of the current state of technology, what we have inside kubelet, covering mostly CPU management, memory management, topology management, how it's done today. Very short one slide overview of that. And then we will go through our proposal, how this can be extended or basically can be done as a pluggable resource management mechanism. We will have some overview of the possible architecture and what kind of steps we are planning. So it's and the final 2 points of the agenda are actually how we want to proceed if the feedback is positive of the approach what we are planning. We would like to open a CAP and basically start a PR process for that. And to show you that this is actually a feasible idea, what we have in mind, I prepared a small demo, basically with which we will cover at the end if we have enough time. Feel free to interrupt me if you have any question. First, let's jump into what's the current state inside kubelet. Inside kubelet, we have 4 managers which deal with resources. Basically, as you know, those are the CPU manager, memory manager, topology manager, and device manager. And this already shows one of the problems what we have. We have 4 pieces managing sometimes the same hardware. Part of them are managing different hardware, like device manager. But basically, one of the issues what we see, 3 of them are not extendable, not really extendable. They are hardly, they are integrated inside kubelet, and if vendors want to put new logic, new CPU logic, if there are changes coming, this is very hard. So keeping up to date with hardware becomes more difficult with the time. Right, and this led this kind of 3 managers. They are somewhat limited They're not exposing the hardware up to the level what we would actually like with future architectures. And this led also in the community, you see a lot of custom-made solutions from users, which saw those limitations of CPU manager and memory manager and others. So a lot of solutions exist out there. And yeah, another drawback is basically if you do configuration of this components like the managers, usually you need to restart kubelet, and a lot of the configuration is done through from administrator, and the level of configuration which the user can do is quite limited, and and always has to go through this mechanism. The other drawback what we see is if we look in today's topology manager, it has also certain limits already on today's hardware or the hardware coming this year. Basically, topology manager runs into limitations because of more complex chiplet architectures, which are hardly you can hardly basically work with the topology manager, and most probably you will lose performance. Right, and the main problem for us is actually having those 4 pieces, and if you want to push, let's say, new code inside, this will blow up kubelet. It will make it bigger. It will make it more complex. Right, so it's really hard for us basically to extend CPU manager, memory manager, having it really integrated inside. That's why we are looking to propose a pluggable architecture where vendors can propose or basically write their own plugins for CPU management and other kind of resource management resources. Right, with the idea that we want to basically make kubelets smaller and somehow have a better separation of concerns inside kubelet and outside of kubelet. Just as a short overview of the architecture of current kubelet, we looked inside the code. The main building blocks of the current architecture, you have a container manager which takes care for the lifetime events. And basically inside kubelet, you have the 4 different managers, and the lifetime events are called for all these 4 managers. Between the managers, you have also separate connections. Usually they are going mostly from the topology manager calling all other managers. The other interesting piece, what we see is device manager is the only one pluggable, so which has some sort of register mechanism, and device plugins, as we know, those are daemon sets. When allocated, when basically created, they call the register function of device manager, and they can be basically instantiated in runtime. The size has some meaning here. We denote with the size actually the complexity of those managers. If you look inside the code, topology manager, CPU manager, number of lines of code of those is growing, and they're becoming more and more complex. The only one which is a little bit smaller is memory manager, but all these components are rather big, which we want to simplify long term. The other kind of important message of the current or important aspect of the current architecture, what we currently see, yeah, one drawback, if we look into the topology manager, you have the bit lifecycle, basically for containers, and the issue what we saw when looking inside the code, it actually has a lot of side effects. This kind of codes inside the topology manager, they're in the mid life cycles, there are a lot of allocations happening already on devices and other managers, which makes it hard to understand, makes it hard to predict from what happens from in terms of later extensions. If you extend it, a lot of things can break, most probably. So this is one of the design things which we currently also found out. It makes it more difficult to extend. So this is what we currently have, and let's move to our proposal. First, we made a short list what are our objectives and goals of such pluggable resource management architecture. The main goal would be to minimize kubelet code base and responsibilities. So basically, we would like those managers and those resource managers basically to live outside of kubelet, to be pluggable. So if you have a CPU resource manager, basically the idea is to be outside of kubelet, and similar to device plugins, it connects to certain registration service, and it becomes visible for kubelet. Then the other aspect what we want to improve, we would like to give a little bit more freedom to users to express more allocation preferences, basically for resources. What you currently do a lot through configurations in kubelet, through the policies, we want to expose this to the user through basically other mechanisms. And last but not least, so we want to enable a pluggable interface so that other parties, other vendors can implement vendor-specific logic outside of kubelet, so that people can have alternatives and can basically implement code which is dedicated to the hardware. And the idea how to manage and main that in the future, what we would like to propose is to have a SIG Node sponsored set of resource plugins, similar to what you have with SIG scheduling, basically. We maintain together with the community a set of plugins, and basically community can push different solutions there, and then those can be instantiated by the users. We would like also to maintain the existing experience of Kubernetes. This means if you think about the classical CPU management and topology management as you have it today in Kubernetes, this should remain accessible through a plugin, which is completely end-to-end test compatible with the current state. So everything what we have today, we want to support it again through a plugin, and basically this would be validated through end-to-end tests what are provided inside of the framework. Any questions so far? Maybe I will do it quick. Or...
I think once you get to architecture is when it'll click.
Right. So those were our objectives and goals, and how we would like to scope that. We are proposing to start CAP for this kind of pluggable resource management approach. We already started also prototype implementation, and together with the community, we can work on a PR where we could cover these plugin mechanisms, and the first plugins basically with new technology, but also covering the existing technology in Kubernetes. We would like to keep existing technology, the existing kind of implementation logic still inside Kubernetes. So basically, we propose to introduce gatekeepers for the new logic, which will be basically which will disable the standard CPU managers, topology managers when enabled. So basically, they will be mutually exclusive, and this will be controlled through a gatekeeper logic. End-to-end test compatibility, this would be our target. We already started working on that in the prototype, and we showcased that it is feasible. We already did that with CPU management and memory management. Performance impact is also important for us, as this pluggability comes with a price. We would want to know that, and we would like to put the cards open on the table for the community to see what's the price having a pluggable architecture, basically. Last but not least, we want to support device manager capabilities as they are existing today. So we don't want to change anything there. So our vision is basically everything what you had as a device code in the past should work together also with this resource management mechanism. In terms of architecture, what we propose looks somewhat similar to what you have with device managers. So it's the natural extension basically to the full resource management, basically. We have resource management plugins, which are daemon sets, and the daemon sets, when instantiated, they register to a resource manager inside kubelets. The resource manager lives in, it's basically controlled by the container manager, and the container manager also communicates to it about lifetime events and policy choices and stuff like that. So first step is registration through the similar to device managers, what you have today, basically through a socket. And as an answer of the registration, we currently basically return the kubelet configuration, which allows us basically in the plugin to know already all the details, what you have about reserved CPUs, policies, and stuff like that. Then after this registration cycle finishes, we start processing the lifetime events coming from container manager. They are usually well defined. You have basically some sort of admission cycle done with allocate at container functions, remove containers when you are basically deleting containers. And some of the managers, like CPU manager, have an internal reconcile loop, which we want to cover through a special reconcile event. Those events basically, after certain allocation happens, we return, if the allocation was successful, we will return the CPU set or a certain resource allocation. This is usually a set of, a structure, a set of assigned CPUs. No, the idea is that actually our plugins do not do any allocations. They return the desired allocation set to the kubelet, and kubelet then basically calls the runtime service. The runtime service provides an interface to allocate all the desired resources, and we use it inside kubelet. So this makes it nice in terms of plugin perspective. We don't need any special privileges here. And of course, there are errors which we want to forward back to kubelet if the allocation is not possible. So all these things we want to capture. This is the main mechanism, what we are thinking about, how to cover basically this kind of pluggable resource management. In terms of implementation of possible plugins, we started with basically something like which covers the existing functionality what you have today. we have a plugin which combines the current CPU manager, memory manager, and topology manager together. They're one-to-one the same code, what you have in the current Kubernetes, and they are not duplicated. So you don't have a code duplication. It's just instantiation of those managers inside the plugin. So actually, code is not being moved. Code is not being duplicated in that sense. As we know, topology manager in this phase, we want to structure the approach in several phases. In the first phase, we basically will need some sort of hint aggregation because topology manager basically relies on hints from devices and other topology resources. Yeah, so we will have some sort of hint aggregation logic inside the plugin, inside this kind of default plugin. The other important building block, what I want to point out, is the device manager. So we want basically a single point of contact manager, to introduce a single point of contact manager inside kubelet for this kind of pluggable resources, and to maintain compatibility with device manager, and basically to not to change the code. We just want to instantiate device manager inside, and all the logic basically will remain the same as you had it in device manager. No code changes are required here. It will just be basically the calls which the different managers here on top have regarding device manager will be handled by resource manager. It will adapt the calls to the device manager. This is phase one. In phase two, actually, as you recall in our previous slides, the architecture resembles a lot device manager as you had it originally. So we think that it's possible actually to have one manager for everything, one resource manager, which can also handle devices. So this would be our phase two suggestion. If we can come up with an approach where we can handle all resources through a single point of contact, single manager inside kubelet. We call it resource manager. It supports basically the same kind of events what we discussed so far. And it is backward compatible with any device plugins what you have currently. And you can then add new resource plugins, and you have also backward compatibility with the standard CPU manager, memory manager, topology manager logic. I stop here shortly for questions. Those are the main points of the architecture which I wanted to show.
Hi, Kevin Clues here. I don't necessarily have questions about it all. It all makes sense what you've said. Yeah, just some background. So I'm the original implementer of the topology manager, and I did all of the refactoring for the CPU manager, device manager, and reviewed all of the code for the memory manager for how it's currently architected and put together. So yeah, so like I said, I don't necessarily have any questions. My biggest kind of worry, so we've tried to do an exercise similar to what you're doing now at some point in the past. I wouldn't say it failed, but it's always a big undertaking because there's so many things that are in place. We've been doing things the way they are. I'm not necessarily happy with the current architecture that we have today. There's obviously many flaws with it. But I slowly over time, at least for my own personal opinion, came to the kind of realization that, to me, it doesn't feel like plugins for any of this stuff really actually belong in Kubernetes, in the kubelet, anywhere at all, and actually belong down at the container runtime level, kind of how the CNI stuff has now moved down to be completely runtime plugins rather than something that runs as a pod inside Kubernetes. We can talk about the details of some of that later, and I'm not necessarily saying that we don't want to go this direction, because this definitely will clean things up quite a bit if we decide this is the right thing to do and there's people to actually put in the effort to work on it. But I do think we need to sit down and have a conversation about whether we even want to continue maintaining these components the way they are. The one thing that jumped out at me when you're talking about, making sure we have backwards compatibility with the existing CPU, memory manager, topology manager, CPU, all these components. If we went to an architecture like this for, for these types of resources, my initial gut feeling is that we wouldn't want to be backwards compatible with any of those, because that carries a bunch of baggage along with it that we don't necessarily want to have to continue to maintain. I'd rather have a set of feature gates that could turn those off and then use this new architecture with its better way of doing things instead, rather than try and maintain backwards compatibility with the old stuff. But yeah,
correct. We are on the same page. So basically here, or our goal would be also this new architecture should not carry this baggage what you have with the old architecture. But the plugin mechanism allows you to have a single plugin which can emulate more or less the old architecture. So if people want the old architecture, they can instantiate a single plugin which does it, and it's made simple for them. But yeah, our idea here is keep the interface or define a new interface which is not driven by the old architecture, but it's actually driven by, a meaningful management of this kind of pluggable resources. And then we want to emulate more or less the current state so that users still can use what they are used with. So, yeah.
That makes sense. Yeah, I'm also trying to think how this fits in with the new DRA stuff that we presented 2 weeks ago, the dynamic resource allocation. We've always said that we want to allow both paths to coexist simultaneously, obviously, because not everyone's going to be able to move off of this style resource management to DRA. Maybe they don't even want to move off of the old style onto DRA going forward, right? So we're always going to have some way to have these two things coexist. And so, if this is the way to clean up the old style resource management, then I'm all for it, if that's what the community decides that we want to do.
So 2 things to note, Kevin. There's actually 2 different KEPs currently. So there's the dynamic resource allocation, which I think we could easily move some of that functionality in here because we are familiar with the code there. And the other one is the QoS one, which actually adds yet another manager. I don't know if you've looked at that yet. In addition,
I've glanced through it. I haven't read through it in detail.
Yeah. So from the diagrams they have, it actually adds yet another manager. And I don't want us going in that direction, but they are solving a real problem. And I noted that you mentioned the NRI piece as well. So
I didn't call it by name, but moving things down.
I know what you're talking about. So what I'm going to tell you is different customers are comfortable deploying at different levels. So this gives customers 2 different levels. By moving this complexity outside of this, you're no longer having to turn off everything for runtime level fixes. You now can just choose not to use the plugin and say, oh, we'll handle it at the runtime level. So you can just choose to ignore this entire processing piece. And if a customer, for instance, has 10 nodes of which they want to do a special resource plugin, they can. So when you're talking about research like at CERN with Ricardo over there, then they can say, oh, well, we want to do some new examples to see if we can get speed ups with certain types of resource managers and do there. This also gets some of the the vendors, because we're at Intel, right? We're not going to hide that. But it lets the vendors start releasing specialty resource plugins for CPU, et cetera, without complicating the community. So the community no longer has to deal with it. So it lets the maintainer sleep at night and focus on keeping things simple and running, and lets the vendors deal with the complexity. So
that's actually not true. For all those plug things, it is a favor of those vendor, which is like, for example, storage vendor. Here is the different type of the resource, computer resource, or whatever resource offer vendor, not really necessary favor of the Kubernetes offer, right? So they also have different type of the platform vendor. So there are so many of the different plugin So then there's the compatibility integration, all those kind of things. So my actually the presentation here, high level I agree, because we try to have the separate of the resource management from day one, actually, but because that's overcomplicated, so we want to make that simple. So that's why we have Nix built-in, but from day one, we think about maybe we should separate. We even talked to Docker back then, say that's which is aligned with Kevin earlier said. We from day one, we basically start to say, oh, can we push down that one to the container level? But that time we really believe push it down to down level will be helpful. But after over 7 years on this Kubernetes, actually sometimes I feel like what you just say, actually the different level of the problem. But the one comment at the earlier try to say, oh, this is a simplified two things, the motivation I disagree here, clearly disagree. When it is restart Kubernetes, most of the time it is the vendor offer, or maybe like the platform offer, or whatever Kubernetes offer. They already will endorse what kind of the plugin, what kind of the resource they are going to support, offer to their customer. So anyway, they are going to provisioning those nodes, provisioning those resources, and provisioning those clusters. So restart Kubernetes is really cheap things. It's super cheap. It's not like the restart node, right? So when you plug into some new resource, sometimes you require the kernel reboot, not even mention Kubernetes restart. So that's not the problem for customer, actually, for user. A lot of cases that's hidden. Like that's the hidden things, like the Kubernetes will restart the node when certain error detect, then we restart the node. We could restart the container D, also maybe like the Kubernetes. So they have the different complexity to the customer, but that's hidden to the customer. Restart the Kubernetes is most cheap one. So another thing is what I mentioned that, that solve that to make the Kubernetes easy, actually is not. I think about so when you have the more things, then you have to combine. If you look at everyone look at the CNCF, that huge gland, and then people keep asking me. My top question actually I received from the Kubernetes user today is, Don, can you tell me what's the opinionated offer from the Kubernetes? I can't, because we have so many plugins. We have so many. Have the one way is the good is the ecosystem, but on other way, user don't know what they should be choose.
In any case, you will not have endable number of plugins. So as you see today, for example, you have one GPU plugin, you have one, I don't know, adapter, network adapter plugin. So they are very clear what kind of plugins you will have. There are not thousands of them. And in terms of performance, okay, you have a little bit better performance if you live inside kubelet and all stuff calling the managers, but the actual performance is the workload performance, what you care about, and not having a correct platform representation with the current state of managers, you leave on the table a lot of performance.
I totally agree with you. I just argue the motivation originally, but I totally agree.
So Don, that maybe is partially slanted by my experience with Kubernetes, because my initial thing, I was working at a AI startup equivalent, and we had a hell of a time restarting kubelet because we had complex networking. And so every time you restarted kubelet, it didn't play in with the network. So actually restarted kubelet meant I had to restart the node, which meant it might not come up well. And I don't think, maybe that environment was unique, but I don't think it's necessarily unique when you're talking about complex things. So I think if you're talking just regular kubelet with, a very simple infrastructure, maybe that's true. But for us, deploying a daemon set was easy. If we were going to have to change anything on the kubelet, it stopped us. So we didn't. Does that make sense? So
once you have this pluggable, so you are going to have so many different daemon set, different implementation. But I agree with the Atlas earlier say, anyway, even today, we have the different of the type of the plugin for this device plugin, right? So we already have that. My point it is to say this is why we are simplify. Actually, it's not. I just want to make that more clear, because once you have that API, there will be tons of the vendor try to implement this one. So end up which one for customer to using. That's the Kubernetes community always try to answer that question, especially on the storage network node side. Will be have tons of those questions need answer. So customer actually is user Kubernetes user today is actually most of the top problem is too complicated because so many choices.
Yeah.
If there's a way we can pull from the SIG scheduling group and how they're doing their plugins, because they also have many plugins, so they may have a different or similar curse of choice.
Maybe related question to this kind of how do we do some role description? So, and how do we do portability of pods? Like, let's say in a connect session or register section, you pass kubeconfig to plugin manager. I assume it's for current topology manager to work as is. So then, like, if it's
so
for current topology manager, what is the ideal plan? Is kubelet will be configured with configuration specific for resource manager, and then how admin will synchronize like resource manager set and like kubelet configuration? That will be a little bit complicated task. So maybe what Kevin suggesting to move this entire logic to container runtime may be a better solution, and then at least admin will know that they need to configure one thing and don't synchronize many things across like version of resource manager and set of plugins installed, and then Kubernetes config, kubelet config.
I think there are two aspects. There is, of course, the container runtime, which yes, admins should have some level of control, but our point here is we want to give more freedom to the user also.
And because by user, we mean user to schedule pods and like this hints like
user being able to choose policies. Basically, if you think about, we spoke with some different customers like telco companies and so on. They express the need to change policies, like between static and I don't know, different topology policies. They want to express it in a spec or through a notation or something. They don't want to express it through a configuration. So some admin might make sense to configure the cluster to have a certain policy, and then users can deploy on that. But actually users want to express that too. So they want to tell, I want to pin cores, I want to run NUMA aware. So all this stuff users want to do. At least there are advanced users who want to use that.
And the role of user who is doing it, is it admin of cluster or like admin of node? Or
no, those are actually, I see those as people coming from, for example, from HPC background, from AI background. Those are people who definitely need this kind of access to more NUMA awareness, better kind of resource allocation. Also, if you think about GPUs, you definitely devices handle that in some way. Basically, they know about the topology and stuff, but there are certain group of workloads where users would like to deal with their kind of topology constraints and not give it to the administrator.
Yeah, in the initial proposal for the topology manager, we had extensions to the pod spec to allow users to control this stuff, and it was decided at the time that no one wanted to change the pod spec for these, for these additional fields that were very specific to topology management. And then the proposal came on the table where we could just use annotations. And then, the argument always against that is that we don't want the, Kubernetes code base itself to be inspecting these opaque types that can be embedded in annotations that don't have any meaning to Kubernetes itself. You don't want the Kubernetes code looking at those and reacting to them. If those are pushed out to plugins, in theory, I guess the plugins can use annotations however they want. but it kind of goes backwards from the philosophy that we tried to push previously.
Right, but this is one of the problem what Kubernetes has today. If you think about the HPC and the AI users, they are drifting to use Slurm.
My background is HPC, and I work at NVIDIA,
Right.
so I know the pain. Yeah.
They drift to Slurm because of that. Right.
I guess my point is, sorry, Don, today we have at least some level of portability, and we have at least some level of understanding, like you configure it here and this is what you get, and that there is no like backdoor. With the plugin model, I think maybe we need to, and I don't have anything against it. Like I know that there are many problems, but maybe we can come up with an idea like how to like split people on roles and decide which roles will do what, and then put at least some limitations on what the resource plugins will do. Otherwise, we'll get into what Kevin describes. Every vendor has very specific set of annotations.
Yeah, basically kept some sort of. I think this makes sense. Yes, kept some sort of limits. Otherwise, yeah.
Yeah, I mean, this is actually one of the things DRA tries to help with, because with the claim parameters, they're defined by the driver. They're checked as part of a CRD rather than being, opaque annotations. But it's a completely different mechanism using something like DRA than this simple device and CPU and memory management that we have in this architecture. So it's orthogonal, but it's go ahead.
Would it be helpful to set up a working meeting later that we can talk with people interested in this, so we can get this going forward? Because we do have code working, we do have some basics. So if we have some guidance on where the community wants it to be, that would be very helpful. And meanwhile,
yeah, I'm happy to join something like that. I'm based in Europe, so if we can have a somewhat convenient time zone, that'd be great. But yeah.
Unfortunately, most of my team is based in Europe for you, Kevin. So I have to get up in the mornings.
Got it.
Yeah, Renell, Dawn, I think this is detailed enough. It requires a working group, subgroup within SIG Node here to cover not just here, but also the things that they mentioned around NRI, so that we can balance the resource requirements coming down from the pod specs and the controller managers right down through kubelet, and then see what we can allocate to the plugins in certain circumstances. Obviously, we need to be able to manage resources across pods, CPUs, other resources, GPUs. We get a lot of requests for this. We want to be able to run small pods or long-running pods with small, quickly running services, fast services in a container, and it's a primary case even in Kubernetes today, right? It's not just all about long-running, pods that are scaled across a cluster, right?
No, definitely we can chat on that.
So I have to do the time check here. So can we convert? Can you share the slide back to the meeting agenda, and also can we convert this to the CAP and continue discussing there? And another thing is, Kevin, and we have the several proposal, especially for the dynamic resource allocator. So can we converging? Can we see what clearly define what's the scope? Because at this moment, there's some overlap here. We don't want to connect the two, right, to address the same problem, but it is actually purpose is different. But there's definitely have the overlap. Can we agree on what kind of things and who is going to address what one thing? Otherwise, I can see that immediately we have to slow down both, right? Because until we figure out, because we don't want two things overlap to address the same problem. And so can we address that first? And then say the both different CAP address what kind of problem, what's the goal? I also agree with Kevin said that it's, if we're doing this kind of things, we may not want to carry off the old baggage here. And but I think there's a certain feature parity maybe we need to consider. You're not necessarily you have to choose exactly feature parity. But do we need to consider, say, okay, well, for customer ask for, the current user ask for this kind of things, how we are going to achieve equivalent something? I think we can start from there. because current API is a little bit tricky because due to the previous baggage and then due to the previous baggage. So maybe we should have some freedom, but for usage, same usage, maybe we need to think about how to handle, provide the equivalent functionality that could be now.
Makes sense. Yeah.
Where do we do that conversation?
Yeah, maybe this working group, what you suggest tomorrow that we do. So, okay.
I'll try to set something up. I guess I'll put it in the Slack channel. Where do you write that?
We can start organizing it in SIG Node Slack. That seems like a good place to start at least.
Yeah, other than that, I think I'm through. I just had the demo. If we have some minutes left for the demo, I can do it. But if you have other agenda topics.
Oh, we only have 10 minutes. So Manu, what do you think?
So I think, Don, what we can do is like we can probably move the planning to the top of the list next week. And
Yeah.
meanwhile, what Ruben and I are asking everyone to do is take a look at that document and then just tell us that you have the time to work on that list. I know that the top 7 that are carried over from 125, like people are actively working on it. But the second table, we're not sure if someone is actively looking into it or planning to allocate time working on it. So just go and say, yes, I'm planning to work on it in 126, and then come back next week when we go through the items.
So how about this? We ask other topical owner and one by one, and then hopefully we can save some minutes for demo. And first to let them go through, because I know the one of those actually nobody. So Windows CLI part sandbox field.
I'm sorry, what was the question? Are we just supposed to say if we're okay, like moving to next week, or?
If you are okay with the move to next week, that will be wonderful if you want. But otherwise, I think about it right now, we can go over one by one. Hopefully, we can have some times. If we don't, we can see what we do to do with demo. Yeah, I definitely want to see the demo also, but we can do through some other channel. Yeah.
Yeah. So for the Windows CRI sandbox fields, I think there's still some active discussions going on in that in that pull request. I think that my question James isn't here today, but it seemed like a couple of weeks ago we were settling on having the same sets of fields for the CRI stats, and then last week there was a demo of a whole bunch of new Linux specific stats getting added, which made me kind of reconsider and say maybe we should keep them as like Windows specific and Linux specific stats. And I think we just need to make a decision on that so that we can move forward with getting the CRI API updated so that we can vendor those changes into the container runtimes.
So I think like David and Peter, you guys are looking at these stats. Do you have any thoughts?
Yeah. Oh, go ahead.
Sorry, I was just going to say, yeah, so like the context, just to add a little more context, the presentation last week was by Daniel, and we're trying to move forward with the CAP there, but one of the big challenges on the Linux kind of side of the implementation for that CAP is we have a lot of other metrics today that people use via cAdvisor. And so one of the ideas we were coming up with in that CAP was that we're going to add basically the missing fields that were served by cAdvisor in the CRI. And so that way the container runtime could serve them, and then the kubelet could basically expose them as Prometheus metrics, kind of for backwards compatibility for cAdvisor. So that's kind of the context why we wanted to add the rest of those Linux stats. Peter, please. Thank you for saying something.
Yeah, so for the stats summary metrics, I could see it possibly making sense to share the structures. But if the handling of those stats are going to be Windows or Linux specific, thinking about like it probably makes sense that the Windows has some specific cAdvisor like stats that are reported through Prometheus. So given the change in scope of the that we're thinking of passing these metrics up through the CRI rather than having the runtime report the CAdvisor metrics directly. I do think that it makes sense to have separate separate objects. We just have to kind of figure out what the if we're going to have any overlap between those objects, or if we're going to have them be totally distinct and have the handling be totally distinct between platforms.
Yeah,
Yeah,
I agree with that. I think it sounds like long term, you know, later down the road, we want to add some Windows specific metrics or something. It makes sense to keep them separate. Otherwise, we're going to come back to the same later probably.
Okay, sounds like everyone agree to separate off the Windows stats, and they just need Peter, David, and we need to just figure out how to represent.
Yeah.
In different structure. Okay.
Mike, did you have something to say too? I saw you.
No, I was just chiming in with the let's keep them separate, the Windows and the Linux. It didn't make sense, I don't think, to make it a common strut, since there's a different view of what they mean between Windows and Linux.
Okay, sounds good. So I think we're pretty much at consensus that we'll want to keep them separate, and we can work out the details in outside of this meeting.
Okay, yep. Thanks. Yeah. So next one is I don't know who proposed here, CRI image pooling.
I think it's Marcus and folks from Intel. Marcus, are you on the call? Okay, I can give a quick one-liner.
Yeah.
So this is basically, okay, you are on, okay.
Yeah, I'm here, but it's not my proposal. So I'm not really sure who did this. So some of my colleagues.
It's from Alexei, but it's fine to move it for the next week. Alexei is unfortunately on the sick leave, so he can't participate today.
Oh, maybe then we move to next week. Is that okay?
Yes. Thank you.
Next one is the host and the node network support for Windows pod. I think that came from.
Yeah, this is me again. I think this one should be pretty quick. This is more of a heads up, and I just wanted to see if Node had any concerns with this. But today you could set host network to true for pods, and if it runs on Windows, it just doesn't do anything, which is a bit confusing to users. And so I was looking at either fixing the validation or doing the actual implementation to get it so that we can join Windows containers to the host's network namespace. And it looks like that's all possible in Windows. So I authored a KEP to kind of propose that. The kubelet changes are going to be quite minimal. Probably update the CRI API because all of the namespacing options are under the Linux run pod sandbox config field. And I think we would want to have some options either more generic or on the Windows run pod sandbox config field. And then the rest of the kubelet updates are just filling in those fields if the pod spec says to use the host network mode. So I was wondering if anybody had any concerns with moving forward with that. The rest of the changes would be in the container runtime to actually wire that up, and we're prototyping that already.
Makes sense. It sounds straightforward. So
thanks. So Marcus.
Thank you.
Thank you, Mark. Marcus.
I'm sorry, I was on mute. So what do we have like 2 minutes left? So I had a short update on the Q/resource SIG that has been updated lately, and I'm kind of trying to get it now included in 1.26. But I think we can have the update next week if we are now running out of time, because I have a few slides on that and kind of what has been happening there.
So Atlas, and we only have the 1 minute, sorry, but I can stay longer. Anyone else, can they stay longer? And also another possibility is just we record your demo and put the record of the link in here. And the next week we make another announcement, so make sure people didn't miss your demo. So you have the 2 options right now. Which one you prefer? One it is we can stay longer, and another one is just people can leave. And if you are interested, if you can stay longer. But anyway, we record today's meeting. Another yeah.
I can try to do it in 2 minutes. It's not a big demo. So Yeah, let me share. So I hope you still see my screen. Right, in terms of demo, what you will see is I have a plugin where I reference two kind of containers. One container has CPU manager set to none, and one container has basically one plugin will be with CPU manager none. The other plugin will be static CPU manager with one kind of reserved CPU. The change is just changing the container. It looks very familiar, most probably to people who wrote device plugins, very similar to that. And then I have an example pod, which basically does load on 20 cores. So what I will do first is just instantiate the non-CPU manager. This is just applying the deployment, and yeah, if everything worked fine, you will see a plugin appearing, and basically inside, sorry, I cannot see some stuff on my screen because of the Zoom stuff. Right. Okay. Inside the logs, you will see that we have a CPU manager with non-policy. And then if I start my workload, which was this load on 20 cores, if my console reacts to commands, you will see basically that the load doesn't get assigned to a specific course. It can move around, basically what you should expect. It takes a little bit of time until the workload gets up and running. Right, you will see something like that in terms of picture. Nothing is pinned, cores can move around, or load can, basically Linux scheduler decides which core to take it. Then I delete the workload, I delete the plugin, and I do a small modification. I use the static CPU manager just by changing the container choice. And I just install the new plugin. If we look at the logs, basically you will see that becomes more, yeah, this time it's a static CPU manager. And yeah, I can now try again the workload. You will see a little bit different behavior. So the cores will not move around. They will be actually compact placed, but it takes some time until the workload comes live. And yeah, just you see the code is all the logs, they are coming from the original CPU manager. It just lives in a plugin, so nothing changed what we are running. But yeah, this is the static CPU manager behavior, what you could expect. Just to demonstrate that you can change policy without need to restart anything. You just instantiate the new plugin and it's done. Yeah, and this is feasible, so we managed to implement it. So, right.
Thank you. So, just like what earlier discussed, what's the next step, right? So that we can have the work group and discussing this one, and especially on what we should converge in, what we should separate from the dynamic resource allocator. And then another one is then convert this into a cap, then we move forward to see what's.
Yeah, so I'm
Great.
happy to take part in that working group, and I know the dynamic resource stuff pretty well. And I also know the existing components that they're trying to, abstract out here really well. So yeah, I think that sounds like a good plan. Let's try and converge on how these two things differ and what the goals from each of them are separately, and we can move forward from there.
Sounds great. I'll start a thread in the SIG Node channel, and I'll tag you, Kevin, and whoever else wants to join can join.
Great.
May target for next week because there's OSSMU this week, so I believe people are busy.
Thank you.
OSSEU.
Okay, that's all for today. Thank you, everyone, and yeah, see you.
Thank you.